questions. Are you ready?
Yes, ma'am.
Okay. So first of all, tell me, what is volume? Yes, Harshita?
Ma'am, the space occupied by any substance is called volume.
Yes. Any object inside our universe always occupies some space, right? That space occupied by the object is known as its volume, right? So the space occupied by any three-dimensional figure in the universe is called its volume. Next, I want to ask you, what is buoyant force? You people know about buoyant force?
Yes, ma'am.
Yes, who will tell me what is buoyant force? Yes, Natik?
Ma'am, there is a thrust of liquid, ma'am, that is also called buoyant force.
Yes. So, see, look here. When you put any object inside the water or any liquid, the liquid will exert an upward force on that object. Okay? That force is known as buoyant force. Now, we also use one other term for this buoyant force. Yes? Upthrust force. So, buoyant force is also known as upthrust force, right? So, in this case, there are two forces acting. Everybody can see? One is weight. When you immerse anything inside a liquid, okay, this is a liquid, and we have immersed a solid inside this liquid. This solid will exert a downward force. That will be its weight, right? This is the weight which acts downwards, and liquid will exert an upward force on the object. This force will be known as buoyant force or upthrust force, right? Now, who will tell me what is the unit of force? Yes, China. Newton. And there is one other unit also. Nobody knows the other unit? Abhi? Yes? GF. So the other unit of force is ground force. Okay. So now before starting the topics, I want to ask you, what you people can see in this picture? You have read the story when you were children? Yes. So what can you see in this picture? Thirsty crow, okay. Anything else you people observe? Yes, Arush?
When the crow is putting rocks in the water, the level of the water is coming up.
Yes, very good. Clap for him. So, here, when the crow is putting stones inside the water, what is happening? The level of the water is rising up, right? So, this shows us something that when you put something inside the water, the volume will rise, right? Volume of the water will rise. Okay. On the basis of these three things, volume, buoyant force and rising of the volume of water, we are going to do Archimedes' principle. So today's topic is Archimedes' principle. Right? So, Sarash, please read the statement.
It is a fundamental concept in physics that explains the buoyant force acting on objects submerged in fluids. It was discovered by Greek mathematician and engineer academics over 2000 years ago.
Yes. So, there was a Greek mathematician and engineer named Archimedes who gave this principle. In this principle, we are going to see the relation between the buoyant force and weight of the liquid. Okay. Now, according to Archimedes' principle, when you immerse any object inside the liquid, what happens? A buoyant force is exerted. Archimedes told us the value of this buoyant force. How much buoyant force will be exerted? When the crow is putting stone inside the water, water level is rising. The rise in the water level, that much rise, the weight of that liquid which is rising will be equal to the buoyant force, right? So, who will read this? Abhi, please read it.
When an object is partially or fully immersed in the liquid, the buoyant force exerted is equal to the weight of liquid displaced by the object. Buoyant force equal to the weight of liquid displaced.
Yes. So, buoyant force will be equal to what? Weight of the liquid displaced. Which liquid is displaced? For example, stone is put in the water. The liquid is rising. This liquid volume is rising. This liquid force. It is decreasing due to the buoyant force. After that, we are going to weigh this beaker which has collected the water level rise. This will also weigh how much? 2 kgs. 2 kgs is the weight of displaced water, and as well as 2 kgs is the buoyant force, right? You can also write it as gram force or kilogram force, because this is the unit of force, right? So now students, let's go to the physics lab and let's perform the practical. So students, the aim of our practical is to verify the Archimedes principle. Okay, we have understood what is Archimedes principle. Now we will do it with the help of a practical, right? What all things we need? We need a Eureka can. This is a Eureka can. It has this spout in it, right? Then we have a spring balance. We have a weight, a metal cylinder with which we are going to perform the practical, and a weighing sheet and a wheel, right? Now, who would like to volunteer for the practical? Yes, please come forward. I will guide you. Please perform the practical, okay? First of all, you have to pour the water in this Eureka can. Up to the spout, just up to the spout, so that it doesn't fall out. Slowly. Put more. Put more. Yes, okay, stop. Let it go out. Put it back. Now, you have to take this metal cylinder and tie it with the spring balance. Like this. Put this metal cylinder into the hook of the spring balance. Right. Now, what is the weight of this? 100 grams. Hold it. So, the weight of the metal cylinder in air is how much? 100 grams. Because we are taking it as force, we will write 100 gram force, right? Weight of metal cylinder in air is 100 gf gram force. Okay? Now put it inside the water. Put it like this. Yes, you can see that when you put it inside the water, some of the water displaces and comes out of the Eureka can, right? Now take the reading of the weight. 90 grams. So reading of the weight is 90 gf gram force when it is put in the water, right? Now take it out, please. Leave it. Now we have to measure. What we have to do next? We have to weigh this volume of the displaced water, right? We will weigh it. How much is it? Tell me how much is it? 52 gf. Now 52 gram force is with this beaker, right? Out of this, 42 is the weight of the beaker. Weight of the beaker is 42 gf. Okay. What will be the weight of this water? 10 gram. So, what is weight reduced? First of all, we will calculate 100 minus 90. Reduced weight is 10 gram. So, buoyant force will be equal to 10 gram force. And what is the weight of displaced water? 10. 52 minus 42, that is 10 gram force. What was the statement of Okay, thank you so much.
Thank you, ma'am.
Thank you, ma'am.